Okay, today is a really big day in calculus because today is the day that you are going to take your very first derivative. So look at your calendar, mark down the day, and write down, record in your journal, today I took my very first derivative. It's a huge day for calculus. Why? Because calculus is all about taking derivatives and then untaking them. That's called an antiderivative. So we'll spend from now until a little bit after Christmas finding derivatives and applying those in situations. And then after that, for the rest of the year, we'll do everything backwards. So today is a really big day. So let's talk about what a derivative is. So let's review. You found the slope of a tangent line last class, and it took a long time. But we basically did it by taking the slope of the tangent line. You guys actually did a limit notation for this. You found the limit as h approaches 0 of all of f of 2 plus h minus f of 2 over h. So you did all of that, and you got a number. And in this example, it said we find the slope at x equals 2 and x equals negative 1. So this is this is the slope when x equals 2, and here is the slope of the tangent line when x equals negative 1. Now notice in both examples we're using the same equation, so the process was the same. The only thing that changed throughout the whole process is the point that the slope changed. So like let's highlight all the differences here. This is different. These are different. So the 2 and the negative 1. Still had negative 3. We have 2 and a negative 1 plus 1, 1 and a minus 5. But that's because the point was different. Okay, so see how really the only thing that was different was the point. So instead of finding this, if I were to ask you to find the slope for this function, the slope of the tangent line at several different points, that would be kind of annoying to go through this process every single time. So instead, we can find the derivative of a function, and a derivative of a function is the formula for the slope of the tangent line to that function at any point. So I can come up with a formula that will tell me the slope of the tangent line at any place I want. So this process is called differentiation. So then looking down, you'll notice here's the formula for a derivative. There's actually two different forms, but in this class we'll stick with this form. Formally, this is called the definition of derivative. So we'll be finding derivatives several different ways. So when I ask you to find the derivative using the definition, then I want you to use this formula, which is kind of familiar because you did it in the last section, except you substituted in an h or a number in for the h, and now we'll keep that h as is. Now we will be taking a lot of derivatives, and you don't want to write the word derivative out every single time. So there's a lot of different notations for derivatives. So if we have a function f, if you're given an f, then when you tell me what the derivative is, you can notate it with an f with that apostrophe. We read that as f prime of x. So you would say f prime of x. Or you would just say f prime. So the of x could or could not be there. So either f prime of x or f prime. Either one of those are fine notations. The other notation that you see commonly happens whenever you're given a function in terms of y. So if you see y in the problem, then you can either write y prime, or it looks like a fraction dy over dx, but we say dy dx because it's one unit. So these are the two notations. And along with probably your next calculus teacher, will always kind of try to steer you away from the y prime, just because whenever you're doing a lot of math, it's really easy to lose the y versus the y prime whenever you're writing stuff down, because that apostrophe symbol is so small that you kind of lose it. And then if you do write dy dx, it makes your life later in calculus a little bit easier. So I am going to kind of steer you away from y prime. So basically, if you see y, give me dy dx. All right. So now let's take our first derivative. Here we go. For the function f of x equals x squared minus 3x plus 1, we're going to find its derivative, and then we're going to find f prime of 2, f prime of 0, f prime of negative 1. So I'll do that part later. But let's find the derivative first. So I'm going to use the definition of derivative, and I will say that f prime equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now our algebra skills are really going to come in handy. So come down on the next line. F prime of x equals the limit as h approaches 0. Now to find f of x plus h, you're going to take this formula, and every time there's an x, you're going to replace it with x plus h. So x plus h here, and x plus h. So f of x plus h is going to be x plus h squared minus 3 times x plus h plus 1. Then I have to subtract f of x. And f of x, they already gave me that formula. There's f of x. So I'm going to subtract that whole function. When you subtract it, put it in parentheses. X squared minus 3x plus 1. All of this is over h. So we will simplify. F prime of x equals the limit as h approaches 0 of square x plus h, you get x squared plus 2xh plus h squared. Then I can distribute the 3 minus 3x minus 3h, bring down plus 1, and then distribute the negative. Minus x squared plus 3x minus 1. All of this is over h. And notice I'm bringing down my limit every single time I'm simplifying the algebra because I'm taking a limit. This is a calculus problem, not an algebra problem, even though we're using our algebra skills. So f prime equals the limit as h approaches 0 of, now let's simplify what we have. Now notice, I have a positive x squared and a negative x squared that cancel. A negative 3x and a positive 3x, plus 1, minus 1. All of those cancel out. Then I'm left with h squared plus 2xh minus 3h all over h. I can factor an h out of the numerator. Factor h out of the numerator. I'll be left with h plus 2x minus 3 all over h. And now I can divide out those two h's. It's getting more simple. Scroll though, it's harder to write. F prime of x equals the limit as h approaches 0 of h plus 2x minus 3. So now I can evaluate the limit by substituting in 0 in for h. So f prime of x equals 0 plus 2x minus 3. So f prime equals 2x minus 3. This is your very first derivative. And so all that work got me a derivative. And what does the derivative tell me? It tells me the slope of the tangent line at any point x. So the question asked me for this f prime of 2, f prime of 0, and f prime of -1. So let's find f prime of 2 first. All I have to do is take my derivative and substitute in the 2. So f prime of 2 is 2 times 2 minus 3, and 4 minus 3 is 1. F prime of 0 is 2 times 3, not 2 times 3, 2 times 0 minus 3, which is -3. And then the last one I need to find is f prime of -1 equals 2 times -1 minus 3. That's -2 minus 3 is -5. So let's talk about what this all means. We have this function f of x. So f of x equals x squared minus 3x plus 1. Remember, that's my original function. And I found a formula for the derivative, but I'll show you. I don't know that we need to look. Let's not worry about this formula yet. So this is my original function. What this information in purple tells me is the slope of the tangent line at any point on the original curve. So on the original curve, at x equals 2, so x equals 1, x equals 2. So at this point right here, at x equals 2, the line that's tangent, is it going to show up? The line that's tangent at x equals 2, this line right here, at x equals 2, has a slope of 1. And then at x equals 0, clear that ink off. X equals 0 is this point right here. At x equals 0, the tangent line, the line tangent to the curve at x equals 0, this tangent line right here, this has a slope of -3. And then at the point -1 on the graph, so -1 right here, that slope, or at this point, the graph has a tangent line at -1, or the line tangent to the graph at -1. This really steep line has a slope of -5. Now the graphs of the derivative formula, we'll talk about those another day. But for right now, you need to know you've got your original function, you come up with a formula for a derivative, and that formula helps you find the slope of tangent lines at any point I want along the curve without having to do this every single time.